Hello everybody. Are you someone who's struggling with maths and scared of the scary notations? Don't worry, I've got you girl. In today's video, I'm going to yap about the imaginary numbers. So here we go. Complex numbers explained for the baddies. So let's just get right into it. Starting off with a really basic equation. Let's say x squared minus 1 is equals to 0. Now to solve this, we would add 1 on both sides of the equation so that it stays balanced. Now these both get cancelled and we get x squared is equals to 1. Now what we do is we take a square root on both sides of the equation. Now this and this get cancelled and we get x is equals to positive negative 1. So what this means is that x can have two values. It can be negative 1 and it also can be positive 1. Easy enough, nothing really complicated. But let's suppose if we have an equation, let's say x squared plus 1 is equals to 0. We would solve it similarly like a previous one we did. X squared plus 1 negative 1 is equals to negative 1. So both these get cancelled and we get x squared is equals to negative 1. Taking square root on both sides, these get cancelled and we get x is equal to square root of negative 1. So all the problem starts from here. So this number under root of negative 1 caused problems because before this we have not seen a negative number inside a square root. So this number was called I. So I is an imaginary number which has a value of square root of negative 1. That means if we multiply I by itself, we would get negative 1 as the answer. So whenever we have a negative number inside of a square root, we can express it in terms of I. For example, we have number under root of negative 9. This can be written as under root 9 multiplied by square root of negative 1. And we know that square root of negative 1 is I. So this can be written as root 9 times I. And we know that root 9 is 3. So this is 3I. So negative 9's under root can be written as 3I. Let's just yap more about this crazy imaginary number I. Let's just take a problem. I raised to the power 2025. That sounds complicated, but don't worry. It is not as complicated as it looks. To solve this, we need to know about powers of I. To solve this, we need to understand what happens when we raise I to different powers. We all already know that I squared is equals to negative 1, right? What if we cubed I? That would be I squared times I, right? Now, we know I squared is equals to negative 1 and that times I, we get I cubed is equals to negative I. Now, what if we raised I to the fourth power? We would get I squared and then square it again. Now, I squared is negative 1 and then square it again, we get positive 1. So, I raised to the power 4 is equals to positive 1. Now, what we need to understand is this cycle repeats itself with the multiples of 4. That is, I is equals to square root of negative 1, I squared is equals to negative 1, I cubed is equals to negative I, and I to the power 4 is equals to positive 1. Now let's just get back to our problem. That was I raised to the power 2025. Now to solve this can be expressed as I raised to the power 2024 times I. Now if we divide 2024 by 4, we get 506. That is 2024 divided by 4. We get 506. So what we're gonna do is, this can be written as I to the power 4 into 506 times I. Now what we have seen earlier is that I to the power 4 is positive 1. So we can write positive 1 raised to the power 506 times I. Now we know that anything raised to 1 is just 1. So 1 times I, that is I. So I to the power 2025 is just I itself. So let's just talk about complex numbers. Complex numbers are generally represented by Z. Now, it has a standard form. Z is equals to A plus B times I. This is the standard form for any general complex number. In this form, A is the real part of the complex number, whereas B times I is the imaginary part of the complex number. So let us talk about what happens when two complex numbers are equal to each other. Here we have two complex numbers and they are equal to each other. A plus B times I is equals to C plus D times I. Now, if these two are equal, then the real part of first number will be equal to the real part of second number, and similarly the imaginary part of first number would be equal to imaginary part of the second number. That is, A would be equal to C, that is the real part, and B would be equal to D, and that is the imaginary part. As we are yapping more about complex numbers, let's just see what is a conjugate of a complex number. For example, we have a complex number Z that is equals to A plus B times I. Now, if we want conjugate of this number, what we would do is replace I with negative I. So, conjugate of this number would be A minus B times I. And a conjugate is represented by Z and a bar on it. It's like a cap on the number. So if we have a complex number, say 3 plus 4i, Z is equals to 3 plus 4i, then Z bar would be equal to 3 minus 4i. Easy enough? There are more topics in complex numbers such as properties of conjugate, properties of complex numbers, their arithmetic operations, etc. But this was a basic video, so that's it for this video. If you want further videos, please comment down. Thanks for watching. Peace out.
Only on them seas if it's breeze. Red ruby the sleeves, Chinese on my sleeve. These wanna be Chun-Li's anyway. Yee-haw.